Hello, today we're going to do a proof of the quadratic formula. So we're going to unravel it. We're not so much going to look at how it works or how to use it, but in some ways we are, because by doing a proof we are doing those things. So we're not going to be using the discriminant, but it will come up in the proof. So the proof of the quadratic formula today is going to be done by using completing the square. So first of all, we need the setup of a quadratic. So ax squared plus bx plus c equals 0. Then we want it in a form where it's just x squared and there's not a coefficient in front. So we divide by a, so we get x squared plus bx over a plus c over a, and then the 0 on the right hand side just stays the same, so 0 divided by a is 0. Now we want it in a certain form to complete the square. We want it so that the value is on the right hand side and the terms involving x are on the left hand side. So if we make a square with the x squared, and then we make a square with the b over a times the x, or a rectangle with those, that equals minus c over a, the value. So all I've done is minus c over a from both sides, and then created a square and a rectangle that we're going to use later on in the proof. So splitting the rectangle in two, we can see that these sides, or these rectangles, are part of the sides of a bigger square. So first of all, if we just split the rectangle into two, we divide it by 2, so we get b over 2a times x plus the other part, b over 2a times x, and that's equal to, again, minus c over a. So putting that into a bigger square, we have the original part, the x squared, plus the two sections of rectangle, and then we'll be left with the top right hand side of the square, a section of it that we're not sure what the value is. But as we have the side lengths of the other rectangles, we can work it out. We can say that the smaller square, the shaded square, is a square with sides b 2a over 2a. So to make the equation balanced, we add the b over 2a squared to both sides, and we've got the minus ca from earlier, c over a from earlier. So now, if we put it in an algebraic form, we can say, well, we've got the square, the bigger square, x plus b over 2a squared, and that's equal to what we have on the right hand side. So we have x plus b over 2a squared is equal to b over 2a squared minus c over a, as we have for the right hand side above. Now, on the right, looking at the right-hand side, we want to expand the brackets, the squared term. So I'm going to write the left-hand side exactly as before. So x plus b over 2a squared. But that's equal to b squared over 4a squared, because b times b is b, and 2a times 2a is 4a squared. And then we have the minus c over a from before. Now we want to make this fraction here, which I'm circling in orange, I want that to have the same denominator as the fraction beside it, so that we can sort of combine them. So the left hand side is as before, x plus b over 2a squared, but that's equal to b squared over 4a squared. And making the denominator the same, we have the right hand side is now b squared over 4a squared minus 4ac over 4a squared. So I've just times it by 4a on the top and the bottom. Therefore, x plus b over 2a squared equals b squared minus 4ac, this should look familiar now, over 4a squared. So that combines them. Now all that's left to do is take the square root of the left hand side and take away the b over 2a term. So x plus 2a plus b over 2a, equals so x plus b over 2a equals plus or minus the square root of b squared minus 4ac over 4a squared. So now I'm going to split this into two square roots. So on the right hand side, the top of the fraction will have its own square root, and the bottom of the fraction will have its own square root. And by doing this, it should look even more like the quadratic formula. So we've got the discriminant now on the right hand side set up. All over the square root of 4a squared. So x plus b over 2a again equals plus or minus the square root of b squared minus 4ac. So we just take the square root of the denominator. So the square root of 4 is 2, the square root of a squared is a, so we get over 2a. And now we minus b over 2a from both sides. So x equals minus b over 2a plus or minus all that we had before. So plus or minus the discriminant, which is b squared minus 4ac over 2a. And now we do as we did before and combine the fractions when they have the same denominator. So this implies that x equals minus b plus or minus the square root of b squared minus 4ac all over, all divided by 2a. And that is the quadratic formula.